Today, what I wanted to do is just spend a few minutes to kind of review some of what we talked about last time, and then I'll go over the lab with you, and then we'll break out into groups and do the lab. So I actually just realized that I don't think I ever pre-assigned groups, so it might take me a minute or two to get that going. Yeah, so all right. Okay, so let me go to my slides and we'll just start here. Okay, so we talked about lapply as a functional, right? And so it's different from for loops because for loops generally we're going to be indexing, right? So we loop through an index 1 to n, right? And then we use that integer in our loop somewhere to store something. Okay, and occasionally, actually, we don't even use the integer. We just say 1 to 10,000 or whatever, and then it just does something 10,000 times. But most of the time, we have to say, store it in the ith element of this thing or whatever, right? Lapply is different in that you don't have to pre-allocate vectors, right? And you just give it the vector that you want to loop over. That's the first argument to lapply always. The vector that you want to loop over, it will then loop through each element, and then you give it the function that you want to apply to each element of the vector. Okay, so lapply is one of a family of functions called functionals, and lapply will always return a list. And this is super nice because it's really predictable. You always know that you're going to get a list in return. Okay, sapply is a variant of lapply that will try to simplify the output if possible. Okay, so you might get a vector in return, an atomic vector. You might get a matrix. You might get an array. All right, but the output from that is going to depend on what you feed it. Okay, and what the output is from each iteration. So as I mentioned here, I think sapply is fine for interactive work, and I would actually encourage it, but I would not use it for any sort of programmatic work. And actually, for me, when I'm writing a script for, like, say, a paper that I want to be reproducible in the future, I still avoid sapply. I still always go with vapply because it is more strict and more predictable. Okay, so there's vapply, and then the other alternative is you can use per, which is strict like vapply, but the syntax is much briefer. Okay, so here's a few quick examples. This is from our simulation that we did. So I'm going to use sapply, and I'm going to loop over a sequence of numbers starting from 1 and going up to 5 and increasing in increments by 0.2. Okay, so 1, 1.2, 1.4, 1.6, 1.8, all the way up to 5. And then I'm going to apply this function x right here. Okay, and x just becomes a placeholder for these integer or these numbers in here. Okay, then I'm saying R norm, 10 observations with a mean of 0 and a standard deviation of x. And then that goes through, it applies, I get 10 draws from a random normal distribution with each of the standard deviations. And then the class I get back is a matrix, okay? And so you can see the dimensions of the matrix are 10 by 21. So there are 21 numbers in this vector that I'm looping over, and each one is returning 10 observations. So that's why we get this matrix in return, okay? We can also do it for things like this. So penguins, right, is a data frame. So we can say sapply penguins, loop through each element of the data frame, which is going to be a list. So each column of the data frame, and then apply something like is.double. And so this is nice because now we get an atomic vector in return, which is a lot easier to work with than a list of the same thing. So we can use that then for things like subsetting directly within it. Okay, so here I'm saying penguins all the rows. And then for my columns, I'm doing this sapply to get back just a logical vector to give me only the ones that are double, of type double. Okay. We can do the opposite by just including an exclamation point in front of it, and that's just going to flip all of these falses to be trues and all of the trues to be falses. Okay. And then the last one that we went over very quickly is v-apply. Okay. So as I just sort of showed, it's really nice a lot of the time to simplify the output. So instead of having a list, I have an atomic vector. That's really nice because they're easier to work with, and we can use them for things like subsetting or whatever, right? So we might want to do that, but we might want to not have the unpredictability that comes with sapply. So that's what v-apply is for. So here is an example of using v-apply with the same exact examples. Okay, so I'm looping through empty cars now, so I'm going through each column of it, and I guess these aren't the exact same examples. I'm saying, give me the mean of each column. But v-apply also requires this fun.value argument, okay? And in that fun.value, you have to tell it the type of output that it returns and the dimensions of that output. In this case, I am expecting an atomic vector in return, so I don't have to specify the length of the vector that I'm getting back, right? I just say 1 to say it's going to be an atomic vector. The only time I need to really change that, it's going to be 1 for you probably 95% of the time, if not more. Okay, so you say double 1, character 1, logical 1, and you don't have to worry about the length of it. The only time you have to worry about lengths is if you end up with something like this one. Oh shoot, where'd it go? This one, right? Where the dimensions are 10 by 21. So if you wanted to return a matrix like this with v-apply, you would have to enter 10, 21. But again, the vast majority of the time, you're just going to be saying the type and then put 1 in there and you'll be good. All right. So v-apply empty cars mean, v-apply penguins is dot double, and then on my fun.value here, I say character. And that doesn't make sense because is dot double is a logical, right? So I get an error, values, result type is type logical, but it's expecting it to be character, okay? So we do logical and we get it right, but we can get coercion at times. So it's a little bit unpredictable to me when this will occur. I'm basically positive, but I haven't double checked. The coercion will occur if, oh yeah, in fact, I even have it in my slides, so I must have checked at some point. Coercion will occur if it can result without a loss of information. So in this case, we say is dot double, that's going to give us a logical, but when I say double is the type I want back, I get 0s and 1s because I don't lose any information that way. Okay, so I could coerce that back to logical if I wanted to, and it'd be fine. So here's an example where I'm using v-apply to loop through the air quality data set to sum the missing data. So I say v-apply air quality. I'm going to apply this function where it takes an argument call, right? Call is now just a placeholder for the specific column I'm looping through. Then I say sum is .na call, right? So sum the missing data within the column. And then I just have a comma here after the body of the function there. And I say double of length 1. And I get something back like this. So ozone has 37 missing values. Solar R has 7, and the rest have 0. sapply, we can do the exact same thing, right? sapply air quality function call, sum is .na call. And this code is more brief than this code, right? This is a little more straightforward. So this is where I am saying, you know, I think sapply is great for interactive work. The syntax is more concise, and sometimes that makes it easier to read, but it is a little less predictable. So then you just kind of have to balance those. All right. So overall summary, for loops are super flexible and there's nothing inherently wrong about them. despite what you might hear people say. I tend to try to not use them very much just because they're so repetitive. Okay, so Hadley has this analogy he uses for a cookbook where it's a cookbook on cupcakes. And it's like every page of the cookbook is essentially the exact same instructions, but you're flipping out vanilla for chocolate or whatever. Okay, and there's like a few things that are changing, but it's a bunch of text each time to really just show you changes from vanilla to chocolate or whatever. And that's sort of the problem with for loops. You have to write a lot of code, and sometimes that code is very repetitive if you're doing many loops, and it sort of confuses what is actually happening in the loop because there's so much stuff you have to sort through. So that's where functionals can really be helpful, because it's like I'm looping through this thing and I'm applying this function to it, right? And it's all within often one line. So that's sort of the main advantage of functionals. So they do require more text and often repetitive. They also, because of those properties, can introduce more bugs, and that specifically if you end up with nested loops, they can be really gnarly and hard to kind of figure out what's going on. The lapply family of functions are really helpful because they help you focus on the function that's being applied iteratively. Lapply always returns a list. Sapply is going to return a vector or an array or a list, and it will kind of depend on the problem there. And vapply is a strict version of sapply that will simplify to what you say it will and nothing else. Okay, so that's just a real quick sort of review of where we were with a specific focus on the stuff that we didn't really get to at the end. Before I jump to the lab, and I'll introduce that, are there other questions about any of that? Okay, so today for the lab, we're going to go to assignments, and then I need to change the CSS on this because you can barely see it when you hover over that, but you can when you hover there, so that's good. Anyway, this is where it's linked, right, in the assignments and then on the topic. And this is what the lab looks like. Okay, so there's basically two parts. The first part, I'm asking you to actually just run this code. So you can just copy this code and paste it into your R Markdown file. Okay, and then you can run all of that code. And then from that, I'm asking you to extract the QR tolerance, which is called in an object called tol, from the model results. Okay, so from M. And then also from M, extract the term labels from the model. Okay, so you're going to want to use str to look at the structure of the list, the model list. And that one is particularly tricky because you have to pull an attribute from an attribute. So I would recommend pulling one level of the attribute, saving it in an object, and then pulling the attribute from that object. That makes sense? So that one's fairly tricky because of that like nested attributes sort of thing. Okay. And then from the list, from this list right here, use at least two different methods to extract M. So M is here, right? So that matrix, use at least two different methods to get that matrix. Extract the third column of M. So you can see this is a matrix of 3 columns. And maintain the dimensions of the matrix. Okay, so don't drop it to an atomic vector. Make sure it still stays as a matrix. And then extract the score for student 7. So here is B. We have this data frame. We have students 1 through 15. So I want just the score for student 7. Okay, and then that's all for that part. So that's the data structures part. And then the loops part, we're going to use the air quality data set, which again is part of base R. And the first thing I'm asking you to do is just split it by month. Okay, so you have that data set. It's got a month column. You're going to split it by month, which will give you a list in return where each element of the list is the data frame for that month. Okay, and it's going to be a named list too, which is also helpful. Then you're going to use a for loop to calculate the mean ozone for each month using that thing you just created here. Next, you will replicate that same calculation using lapply, sapply, and vapply. And then I'm asking you to produce separate plots showing the relation between ozone and solar R for each month. Okay, so you're still using that by month list object, but you're creating plots for each of those. And then finally, use a for loop to save the plots to your folder, to a folder on your computer. Okay, so this is this last one in particular, I think is a little bit tricky, but there is an exact example of how to do both of these in the slides. So just check that out. Make sure you do save it to a directory. Like I would create a plots directory in your project, and then save them all to that plots folder so that you don't end up polluting your project, like the root directory of your project. Okay. Any questions on any of that? Okay,